Welcome back to All This Math. This is Professor Parker, and we're doing some more area word problems. All right. So the actual word problem, of course, is found in the description underneath of the video, and I'm going to read it aloud. While you read it, you can read it silently, or but I actually suggest that you read it a few times because I always recommend for students to read problems multiple times. Okay. So the problem reads as follows. The square-shaped plaza, this is it right here, the square-shaped plaza, right, at the center of a small village has an area of 100 square meters. Not the village, but the square-shaped plaza right here has an area of 100 square meters. How can you find the length of one side of the plaza? So the length of one side of the plaza. So this is what we're looking for. We're looking for basically this. All right. But let's stop and let's think for a minute. What do we know about squares? What do we know about squares? We know squares are quadrilaterals. It means they got four sides and they got four right angles. But what do we know about those sides? If it's a square, all four of those sides are equal. They're congruent. They're the same length. All right. So that's one thing. What's the formula for area of a square? Well, we can use a couple formulas for the area of a square because, for one thing, despite what we might have learned in elementary school or what might have been insinuated to us in elementary school, squares and rectangles are not different shapes. A square is actually a type of rectangle. When you get to geometry, you'll realize that, or you'll be told that a square is a type of rectangle. A square is just a rectangle that's got four equal sides, right? Rectangles are quadrilaterals that have four right angles, and they have a pair of parallel sides and a pair of congruent sides. But a square is a rectangle that has four equal sides. All right. So if I was going to do this algebraically, I would first write the formula for the area of a square as area equals side squared. Now that's the formula that you should memorize. Area equals side squared, right? And then if I'm trying to solve for S, because that's the length of one of the sides, and that's what I'm trying to figure out, this question mark on the side and this S stands for side, they represent the same thing. I know the area is 100, so I can replace A with 100, and I got 100 equals S squared, right? So if 100 is equal to S squared, I'm trying to get S by itself. So that means I got to get rid of the exponent 2. So if I get rid of the exponent 2, I can only do that by taking the square root. So if I do the square root of S squared, and then I do the square root of 100, then I got S, and then I got 10, because the square root of 100 is 10. So the length of one of the sides must be 10, right? Because in order to find the area, you do 10 times 10. You do one side times one side. Now, another way to look at it is, since we know that a square is a type of rectangle, that means that the formula for the area of a rectangle will also work in order to find the area of a square. So we could also say that area equals length times width. But except in this situation, we know the area is 100. We don't know the length or width, but we know that these are the same number. Because in a square, all the sides are the same. So that means the length and the width are the same. The length and the width are the same. So what you could try to do is just kind of think intuitively and think to yourself and try to figure out what number can be multiplied by itself to get 100. Even if you didn't know how to do all this algebra right here, right? You basically just try to think to yourself, think of the multiplication facts that you know, and think what number times itself equals 100. And if you know your perfect squares, you would know that, 10 times 10 is 100. So that means that the length of one of the sides must be 10. And, L and W are the same because it's a square. Because in a square, if this was the length and this is the width, they're the same measurement anyway. They're the same number. So it doesn't matter if I say L equals 10 or if I say W equals 10. It don't matter. All right? So that's just one way to do that. All right? But I like this problem because it forces you to think. Right? It forces you to think and figure some things out. Because if you know the area and you know the formula and you know something about a square, all four sides are equal, and you know how to find the area of a square, then you can either just figure it out, what number times itself is going to be equal to 100, you say, oh, that's 10. But if you know some algebra, you can do it this way using a formula. Area equals s squared, 100 equals s squared. Get rid of the exponent to solve for s. The opposite of squaring something is taking the square root of something, so that's what you do. And when you're solving equations, you always do opposite operations to get rid of things that you don't want. So you end up with 10 is equal to s. And there you go. All right? So I hope that made sense. Try to get some practice problems that look like this from your teacher in order to practice and master this skill. And I'll see you in the next video. Peace.